equal to 1.27 ampere. Example 3. Determine the nodal voltages for the given circuit. So this one is the original circuit and it has been redrawn over here like this for simplification. In this particular network, there are 4 nodes. This is the reference node or zero potential. This is node 1, this is node 2 and this is node 3. Node 1 has been assigned a voltage V1, node 2 the voltage is V2 and node 3 the voltage is V3. If you observe carefully, each of the current sources in this network has a negative current assigned to it. The negative polarity basically indicates that the actual current flowing through the circuit is in opposite direction to the assigned direction of the current source. In other words, over here the current source shows that a current of 8 ampere is flowing in the upward direction. However, in reality, this current is flowing downward. Hence, this negative sign has been used to indicate that. Now, while writing down the linear equations, if you consider that the direction of the current is the same as the direction assigned over here, then you need to use the negative sign. However, if you assume that the direction of the current is opposite to the direction assigned, then you don't have to incorporate the negative sign while writing the linear equations. So, using all these conventions or using all these assumptions while writing down the linear equations after applying KCL across node 1, node 2 and node 3, these are the 3 equations that we'll get. Solving these 3 linear equations, we can easily determine the value of V1, V2 and V3. The value of V1 will be equal to 5.412 volt. The value of V2 will be 7.736 volt and the value of V3 will be 46.32 volts. Supernode analysis using independent voltage source. Supernode is the equivalent of supermesh in node analysis. In the last lecture, we have studied that if a current source exists between 2 mesh, then the current source must be deactivated and the 2 mesh must be considered as a single supermesh. Well, in case of node analysis, if a voltage source exists between 2 nodes, then the voltage source must be deactivated and the 2 nodes in concern must be considered as a supernode. In mesh analysis or supermesh analysis, the current source is deactivated by means of an open circuit equivalence. In case of supernode analysis, the voltage source is deactivated by means of a short circuit equivalent. For this particular network, the voltage source over here has been replaced with the short circuit equivalent. Thus, node 1 and node 2 will now be considered as a supernode. Based on the direction of the currents, on applying KCL, sum of the currents entering the node must be equal to sum of all the currents leaving the node. In this case, 6 ampere and I3 are the currents entering the node. I1, I2, 4 ampere and I3 from this point are leaving the node. Thus, substituting the values over here, we can easily determine one of the linear equations, which is V1 by 4 plus V2 by 2 will be equal to 2 ampere. Relating to the defined polarity of the voltage source E, we can generate the second linear equation, which will be V1 minus V2 equals to E, which is equals to 12 volt. If we solve these two linear equations, then we can easily determine the values of V1 and V2. V2 in this case is 1.33 volt with a negative sign, and V1 is equal to 10.67 volt. Using these values, we can easily determine the value of I1, I2 and I3 as shown over here. In this particular network, there are 3 independent current sources and 1 independent voltage source. Just how we solved the previous example, we can also solve this network. This voltage source must be replaced by a short circuit equivalent. Then the node V2 and V3 can be considered as a single super node. Generating the 3 linear equations by using KCL and then solving them, we can easily determine the values of V1, V2 and V3. The solution is given over here. Please go through the solution very carefully. Node analysis using dependent current source. For this particular network, we have to determine the power supplied by the dependent current source. This network has one independent source of 15 ampere and a dependent source of 3I1. I1 is basically the current flowing through the resistor of resistance 2 ohm. The approach to solve this kind of network with node analysis is exactly the same how we have done in the previous examples. At first, we need to identify all the nodes. Then we have to assign a distinct voltage to each of these nodes. Then apply KCL to all the nodes except the reference node. On generating or deriving the linear equations and solving them, we can easily determine the nodal voltages. Using these values, we can easily determine the power supplied by the dependent source. The solution for this network is given over here. Please solve the circuit yourself and then try to match your answer with the given solution. This is another problem on node analysis using dependent current source. The solution to this problem is given in the next few slides. Please try to solve this problem by yourself and then match your answer with the given solution. The last topic to be covered in this lecture is supernode analysis using dependent voltage source. The approach is the same as we would do for an independent voltage source. That is, we need to deactivate the voltage source with a short circuit equivalent, then consider the nodes involved to be a single supernode, apply KCL to all the nodes including the supernode, determine the linear equations, solve the linear equations to determine the unknown nodal voltages. The solution for this circuit problem is given in the next few slides. This is the end of this lecture. Thank you.